Commercialization of space is leading to a massive growth of space infrastructure within low Earth orbit. Docking is a common occurrence at the International Space Station with assistance from the station's multiple robotic arms. Robotic-assisted docking will be used for future missions involving in-orbit servicing such as refueling or repairing of spacecraft and satellites, as well as for in-orbit manufacturing and assembly of large complex space infrastructure. Autonomous robotic docking has been demonstrated before and is an imperative maneuver for any space infrastructure. Nevertheless, there are ongoing challenges for autonomous operations such as the reliability and flexibility to handle various complex situations in the real world. Therefore, a teleoperated control system is usually required to prevent catastrophic mission failure. Extend Robotics set out to perform a feasibility study of using a virtual reality human-robot interface software to demonstrate human-assisted robotic docking in a simulated space environment. The goal of using the Extend Robotics interface would be to lower the interface hardware cost, reduce operator training time, and increase the teleoperation speed. In the experiment, 2 robots were used, each with a serum adapter with magnets and visual assistant cues attached. The serum adapter is a standardized, multifunctional docking mechanism. The left arm acts as a target and holds the serum adapter in simulated zero gravity. The service arm was then controlled remotely by an untrained operator using virtual reality. This allows the operator to see the environment in full 3D with many different perspectives possible, while using grab and pull gestures to control the robot end effector naturally. Both arms were tracked using motion capture to measure the accuracy of the robot's movements. The test was repeated 12 times from different starting positions, with and without obstacles. The result achieved was a 95% docking success rate, taking an average of 44 seconds to complete the docking, with the average docking error of only 1.9 mm. VR teleoperation will one day enable complex structures to be assembled in space using human-robotic collaboration. Extend Robotics is here to provide the next generation of human-robotic interfaces. The project was funded by the UK Space Agency, an experiment conducted in the Star Lab orbital robotics testbed facility within the University of Surrey.